As the world struggles to eliminate fossil fuels, hydrogen is expected to play a leading role in mobility to fuel cars, trucks, ships and airplanes with no pollution. Over the past few years, engineers have been developing new technological solutions for the transition to efficient and sustainable hydrogen production. The CH2P project goes in this direction by developing an innovative system prototype for hydrogen cogeneration to be used at hydrogen refueling stations.
CH2P is a project receiving funding from the Clean Hydrogen Partnership, and it's related to the development of an innovative solution for hydrogen refueling station and distributed applications. CH2P is developing a novel technology aiming to co-generate in a flexible way hydrogen power and heat, using methane-rich gases and mixtures such as biomethane or biogas, and outreaching a positive impact for the environment. It is integrating a technology based on solid oxide fuel cells that are providing support to this poly generation. CH2P has four main objectives. The first is the realization of a technology and solution which is compliant with the introduction of the alternative fuel infrastructure regulation by the European Commission. The second is to have a technology and solution which can bring flexibility on the generation, meeting end-user demand at the refueling station. The third one is generate hydrogen at a very high purity level. And the fourth one is to reduce the costs of hydrogen generated at the station using an innovative cost model.
The secret of the CH2P prototype lies in the high integration of hot and cold components to support operations of the large stack module based on the solid oxide cell technology. The engineering processes of the system posed several challenges that were successfully overcome by the project partners.
The first step was to scale up our stack technology, our SOFC stack, from a few kilowatts to something that can reach the range of 7/10 of kilowatts. We have basically multiplied the power of the stack by a factor of 4 to 5 as a building block for industrial applications. The second challenge was then to bring these stacks together in one module, the large stack module, and to make them work well together. The next challenge was then to create a system around to operate in CH2P mode, so in hydrogen cogeneration mode, and to create basically the conditions for the stack to operate well. And the final challenge was to integrate the whole thing into one industrial plant with a purification section together with our partners and to make the whole plant work well together.
The pilot CH2P, in fact, includes an innovative purification system based on a pressure swing absorber that guarantees high purity of hydrogen in line with the automotive standards.
The main application for this CH2P system is for the automotive sector. There you need hydrogen of very high purity, so very low in CO content, very low in nitrogen, but also very low in water content, because it's used in a fuel cell inside the car and you cannot allow too many contaminants in your hydrogen. In the pressure swing absorber we purify the hydrogen. You have a vessel filled with some adsorbent material and you let a raw hydrogen flow passing through there, and then the contaminants are absorbed on the sorbent material inside the vessel, and pure hydrogen exits the vessel.
The integration of multiple components allows the modularity and flexibility of the system, which can produce 25 kilowatts of electricity and deliver at the same time up to 20 kilograms of hydrogen per day.
One key aspect of the CH2P prototype is the fact that the production of these two products can be modulated. We can go from only hydrogen output to only power output, or modulate in between these two. And this is a key, let's say, aspect of the CH2P prototypes if we consider the application of such prototype in a hydrogen refilling station. So this allowed to more easily scale up such system for larger production.
CH2P, fueling the transition to hydrogen mobility.